Hello everyone. In this video, I would like to tell you about how to refine crystal structures. Now it's actually very important when we solve the initial structures. We need to refine the crystal structure to final form because this is the part where we improve the accuracy of atomic positions and through thermal parameters we try to rectify the overall model based on our chemical knowledge or pre-assumptions. Here we have to know scattering factor or F factor, which is the scattering power of the atoms, and R factor or residual factor, which is nothing but the difference between the total observed scattering factor and calculated scattering factor divided by total observed scattering factor. While refining, when R factor is less than 0.05 or 5%, we can say it is a good agreement. Here I have already solved some molecular structures. For this, I have used Olex2 software and Vesta for crystal packing and powder XRD pattern simulation. In this video, I am going to show how we refine a structure in Olex2, generate a report and zip file, and then we will learn to generate powder XRD pattern in Vesta. Now let's start structural refinement in Olex2 software, for which we will require .hkl and .ins file, which contain unit cell information of a crystal lattice. I have already downloaded it and now let's open it. It took some time, but now it is finally opened. So here at first we can see some ball-like structures which are known as Q peaks. Now I am just clicking on refine button just to check initial R factor, which is 38.92%. By solving the structure, we are going to reduce the R factor. So now let's start. At this point, we have to assign Q peaks with atoms like carbon or nitrogen. So at first, we have to find where the perfect atom is going to fit. Here we can see a planar hexagonal structure forming. It might be a benzene ring. Let's assign the Q peaks as carbon and refine it. See, R value reduced to 30%. Now we need to assign other atoms. Here we can see another benzene ring like structure. Let's assign these Q peaks as carbon and refine it. Here we can observe this carbon atom is out of plane, and also this is much bigger circle than others, which is because of inaccurate assignment of element. This Q peak indicating more electron density than it was assigned. Nitrogen has more electron density than carbon, so let's try it with nitrogen and now refine it. See, R factor has reduced. Now, if we carefully observe, these green atoms which are assigned as chlorine are little smaller, which indicates wrong assignment of electron density. So let's assign them as sulfur and refine them. R factor slightly reduces. Similarly, for this yellow one, let's assign this as chlorine and then also refine it. It seems slight reduction in R factor. To refine a crystal structure, actually we should know the actual structure or formula of the molecule. Otherwise, it would be very hard to refine the structure. In this case, I also knew the actual structure where each sulfur bonded with 2 oxygen atoms. So let's assign the oxygen atoms according to that. Here, these Q peaks are much more intense, indicating high electron density. So let's assign them as oxygen and refine it. See, there's a gradual decrease in R factor. It seems we are halfway done with the refinement of our crystal structure. Now we have to assign the nitrogen atom bonded with sulfur and let's refine it. After refinement, we can see R factor again reduced. Now let's assign remaining nitrogen besides the benzene ring and refine it. Now finally, our crystal structure looking same like our target molecule. But there's still more to go. We haven't added hydrogens yet. Let's add hydrogens. Here in toolbox work is an option of add hydrogen. Click it and refine it. Now when hydrogens are added, we are checking once again. Here this nitrogen is bonded with 3 hydrogens, which is not possible here. So let's remove this hydrogen. Here right click and delete it, and then again refine it. Yes. Now we can say we almost solved our structure, but here we have to notice that these boxes should be green, not in red. So we need to do anisotropic refinement. Here, due to thermal vibrations within the material, the effective volume of the atom appears larger. That's why electron densities cannot be shaped as spherical here. We need to do anisotropic refinement. Such thermal motion in atoms is known as Debye-Waller factor. After refinement, we can see R value reduces to 3.76%, from which we can interpret our solved structure has a good agreement with actual structure. Now, we have to label each atom, then we can finally generate report file. For labeling, we have to select atom names from labels, which will label each atom separately, but numbering is sometimes poorly arranged. Then we have to manually assign name of each atom. In such case, we try to label atoms from one side sequentially. Not compulsory though. Let's assign this carbon as carbon 1. For that, we will select this carbon, then here we have to click, then information about this carbon will come out and we have to edit this as carbon 1. Same as this, we have to label all atoms. Then if we refine, all the atom names will be saved. After refining and labeling each atoms, we refined for sometimes until the shift becomes 0. With that, all boxes becomes green and thus we are ready to generate zip file. To generate zip file, first we have to click down arrow beside refine button, then have to select acta like that. Thus, zip file will be generated automatically in parent file. Then we clicked on report button, thus final refinement was done and report file was generated. Here all the information of molecule was given. Unit cell parameters, space groups, A, B, C, alpha, beta, gamma, bond length between each atoms, bond angles, all the information was given in the report file. Now we need to check whether CIF file was generated or not. So we need to check the folder where HKL and INS file was kept. Here we can see CIF file was generated. Now we move forward to Vesta for crystal packing and powder XRD. In Vesta, we need to open file where we select CIF file and open it. Now we can see generated crystal packing of our refined structure of crystal. This is the unit cell of the crystal and these are the molecular arrangement in periodic manner. In Vesta, we can modify our crystal structure as well as we can predict powder XRD pattern by simulating the crystal structure. Now let's see how to simulate PXRD pattern. For that, we have to go to utilities, then we have to select powder X refraction. Then it will show all the conditions. We need to calculate according to that just by clicking the calculate button. Then select the plot button and there we go. Our simulated PXRD pattern got generated. So in this video we have learned how to solve crystal structure, how to generate CIF file and how to generate powder XRD through zip file. Thank you.